科技日新月異，為我哋帶來便利嘅同時，亦改變咗人類嘅生活。好多創新科技其實都係為咗解決生活上嘅問題而研發。以城大電機工程學系為例，佢哋研發嘅科技唔止先進，仲以人為本，可以應用喺生活唔同嘅層面，造福人群。我哋一齊去了解下。疫情爆發以嚟咧，科學家努力通過 DNA 分析，揾出病毒嘅神秘面紗。今時今日，其實好多疾病都可以由研究基因揾出源頭，但係要精準分析，必須借助數據同計算法嘅科技去幫助。城大電機工程學系近年喺呢方面取得非常之好嘅突破。
2002年爆发 SARS， 专家花了好几个月才确定和破解它的基因组。这次 COVID 只花了数星期就获得致病病毒的基因组，为快速检测的设计和疫苗的开发争取了宝贵的时间。这些成果都是因为 DNA 测序技术和相应的分析方法的进步带来的。DNA 还有 RNA 序列是自然界中所有生物体的遗传物质，造成传染病和流行病的微生物，比如细菌和病毒，同样含有 DNA 或者 RNA 序列。这些序列看着非常的简单，比如这里就是造成 COVID-19 的 RNA 病毒的基因组序列。但是看似枯燥的 DNA 序列蕴含了关于这些生物体的所有秘密，因此它们被称为生命的蓝图。当我们能够破解这些生命的蓝图，就能更好地控制和预防传染病和流行病。DNA 的分析是个 teamwork， 需要很多不同领域的研究。其中的一个挑战是如何从大量的 DNA 数据中挖掘出有用的生物知识。这就是我的研究方向，叫做生物信息学。我们用计算方法、机器学习 AI 来分析大量的 DNA 数据，破解生命蓝图。我们最近进行的一项研究，如何在一个样本中全面地识别出所有的病毒和具体的毒株。这种广谱的病毒识别技术既可以用于诊断，也可以用来预防疾病。比如说，有些病毒可以在血液中潜伏数年，却不会造成明显的症状。这种方法可以帮助患者早日發現疾病，為治療爭取時間。
環保係世界嘅大潮流，平日衣食住行都可以體現。例如，我哋選擇坐電動車，可以減低碳排放。不過，目前電動車嘅電池技術仍有待進一步改良同埋提升。城大電機工程學系一直關注呢方面嘅研究。
Apart from the energy density limit of the battery, the electrical vehicle deployment is also challenged by the traction inverter and the battery charging process. And the traction inverter converts the DC power from the battery to EV motor, and then we have the electrical propulsion. In general, it is very demanding to have high energy efficiency traction inverter with high reliability and also long service life. And thus you can drive farther and safer. And in terms of the charging process, the current cable charging is dominant, but suffers from the manual plug-in and also the metallic contacts and also the possible electrocution, and which may suppress the EV promotion. While the wireless EV charging can well address these problems and offer better convenience and safety. For a traction inverter up to 100 kilowatts, we are exploring new topologies, switching schemes for the parallel connected silicon carbide transistors instead of a single module to reduce the switching loss and enhance the reliability. And for example, if 1 kilowatt hour could be saved for a battery, it means you could have a range bonus of 6 kilometers. And for the wireless EV charging, we are exploring a novel magnetic material, the narrow crystalline ribbon, for the next generation wireless EV charger to have less core loss and higher magnetic saturation. And with the help of these emerging technologies, we can drive farther and safer and more conveniently. It is our mission at CityU EE to promote the more energy-safe technologies applied in our daily life. And so far, part of our newly developed techniques has been applied for the EV and other industry power converters. And we will keep elaborating on wireless EV charging and improving the system's convenience until the high public acceptance, just like you are using the wireless charging for your iPhone.
我哋日常生活好多電子產品咧都要用到晶片，細細一塊晶片，效能大到令人意想唔到。城大電機工程學系致力晶片研究，除咗提升效能，仲開發更多尖端嘅科技。神經形態晶片係其中一個方向。
These days we hear a lot about computers being intelligent. There are smart speakers like Alexa and so on, but they're very different from how humans or animals are intelligent. So neuromorphic intelligence tries to bring us closer to biological intelligence. That's why it's a very natural fit to a patient's brain. For example, they can help a paralyzed patient control a device like a wheelchair or browse the internet without needing help from anybody else. We can see ICs everywhere in our daily lives. They are there in your smartphones, laptops, refrigerators, automobiles, everywhere. But very different from these digital ICs, the ICs that we build are similar to the electrical circuits in our brain. So that's why they require about 1,000 times lesser energy, and it can open up a lot of new applications. The current technology for paralyzed patients to control a device requires wires to come out of their head and connect with the PC. There are two problems with that. Firstly, because of the computer, it's a bulky system, and secondly, there's a risk of infection because of the wires coming out of the head. Wireless implant would actually solve these issues, but current technology would require frequent recharging 2 to 3 times a day, which makes it very inconvenient. So this is where neuromorphic ICs can help. Because of their low energy requirement, they can actually run for a very long time without requiring recharges, and that really improves the quality of life of the patients. Indeed, there are other ways we can use these ICs, mostly in battery-operated devices. For example, in medical applications, we can think of using these ICs to monitor the breathing sound of patients at home, especially patients with COPD, common breathing disorder. Separately, we have also used these ICs for intelligent transportation systems, where we have connected them with a camera and used them to monitor traffic. Then we can give an early alert to a pedestrian or a vehicle to avoid accidents.
睇完咁多科研嘅項目，相信大家都明白到呢啲科技有幾創新，亦感受到城大EE科技無處不在，同你我嘅生活息息相關。